Hi, my name's Nathan, and today I'm going to talk to you about my BTEC project named HANMAP. First up, just a little bit of a background into why I'm doing my project. In Australia alone, cerebral palsy is diagnosed in over 740 children each year. And globally, there are 17 million people living with CP. People who live with mild CP tend to live a fairly normal life. However, tailored splints are actually a common approach to managing the condition in a more effective way. Splints are something that people with CP might have to deal with their entire life. This means that new splints must be generated to meet the bodily changes. In the past, splint creation required plaster cast molds to be taken. Technology nowadays has allowed for splints to be created using advanced imaging techniques. However, this normally requires a visit to medical centres that has the specialised equipment. The process can be especially confronting for children who require splints during the early periods of their life. Due to complexity and cost, a lot of families will simply not go through with the treatments. And this is where I come in. I want to develop a cheap, easy, and accessible method for families to generate images at home and to have their splints manufactured without having to visit a medical centre. What this will mean is I'll need a way to apply quick and computationally cheap imaging processing techniques to commonly found household cameras, like an iPhone or an Android. From there, I'll generate 3D rendering of a hand based on the 2D images from the camera. And above all, I want to make the process fun and not confronting to small children. When I was deciding what kind of tools I'd like to work with on this project, I mainly opted for open source libraries. Things like OpenCV, or computer vision, NumPy, Matplotlib, and Mahatos, which I'm not sure if I'm going to use yet, are all libraries that are open, free, and accessible. I'd also like to state that I am initially writing the software in Python due to ease of use, but the nature of the OpenCV libraries means that I'll be able to port it to a variety of different languages. The reason why I've picked some of these libraries is because I'm not looking to reinvent the wheel. There are already existing projects that I'm going to be adding on and using, basically building them like Lego blocks into my final project. I'll also be able to make use of the OpenCV documentation, and there are already numerous classification techniques, but nothing that mirrors my proposed solution exactly. Now let's take a look at image manipulation. Image manipulation in OpenCV is very easy. It's one of the simplest techniques and have some very powerful results. It also allows interaction with images, or lots of images in real time, also known as video, and at a very fast rate. In my early testing, I've been able to completely scan and manipulate images at a speed of up to 60 frames per second. So let's actually take a look at some of these techniques. For starters, let's look at edge detection. Methods for detecting edges are actually a critical milestone in the early stages of my project. If I can detect edges, I can outline a component or an object that I'd like to track. Laplacian, Sobel, and canny edge detection algorithms are widely used already for this method. So there's a very good chance I'm going to pick and choose certain components from those algorithms in my final solution. Something I do need to be very careful with, though, is how I implement these methods. Things like environmental variables, object types, design reliability are all extremely important factors when it comes to picking and choosing the methods I want to use. For example, in the animations you can see on the right, you can see the top image represents the kernel size of a standard Gaussian blur function, whereas the bottom represents the thresholds of the X and Y values for my canny edge detection. I need to find the optimal locations and variables in which to apply these to my transforms to get the best result. This will typically mean some kind of calibration. This actually brings me to my next slide, which is on the issues of edge detection. It normally requires some method of calibration because the lightness and darkness of the room, the object you're trying to scan, is always going to be slightly different. It's never going to be the same. Calibration is normally done fairly quickly, but if you do it at the wrong time, you can generate something that looks a bit like lag to the end user, which is not something you want. So typically these kinds of processing are done in conjunction with the main programming loop, and that's something I'll need to investigate. As stated before, the complex environments is also a big factor. On the right-hand side, you can see I'm running a variation of edge detection that relies on the high brightness of certain objects in the image. Now, my face and hand have the same sort of brightness, as does some of the wall in the background. Because of that, the representation of the hand that's picked up isn't completely accurate. The next type of classification or detection method I'm looking at is HAAR classification. It's a popular method for object detection. and it uses a set of positive and negative images to come up with your result. The classifier employs a method of training that's used to recognize types of objects. For example, on the right-hand side you can see a set of bananas. The top bananas would be my positive images. Positive images define exactly what I'm looking for in that object and typically should exclude as much of what's not the object as possible from the image. An example of negative images are basically anything that is not the object you're looking for. So typically your negative images will outweigh your positives by a factor of 10, 20, even 1,000. The example on the right, I've used 20 images of bananas in various scenarios. And I've used 600 images that were not bananas and ran them through a classification engine. The outcome was that I was able to detect the 3 different bananas that the lady was holding. And this is great, and it works, until it doesn't. One of the problems with this method is that unless you've adequately trained it for every possible scenario, it will sometimes get things wrong. For example, if you take a look on the right, the banana has not been detected because it was perceived in the image as sideways, whereas the guy's chin has the shape of the banana, but it's obviously not a banana. So I thought that was kind of an interesting example of how this algorithm can go wrong, or how this method can go wrong, I should say. It does rely very heavily on strong positive images, and a lot of thought needs to be taken when deciding what you should include. This is the image training set. The images used to train the classifier are very, very specific to the application. Using a classifier for hand detection might work very well when you're looking at a typical hand. However, some of the challenges that I've faced so far is that when I'm using pictures of my partner's hand, who has mild CP, it wasn't able to detect the center of the hand because her hand doesn't look exactly the same as the ones I used for the classification. Another aspect that needs to be remembered is that the process of generating a classifier takes an extremely long time and is very computationally expensive. For me to generate the hand classifier took roughly 2 days, and that's something that needs to be thought of. So let's take a look at what we found out so far. My hypothesized solution is going to be a hybrid approach. It's going to use a mixture of techniques to slowly break down components of the captured images. I would first convert the image captured to grayscale, use a HAAR classification to find whether or not there is a hand object in the image, which will narrow down my search results. From there, I'll run a canny edge detection applied on the area that the hand was detected in, and finally run a bounding box around the outside of the hand so it's easier for me to manipulate. Finally, I'd like to invite people to get involved. If you'd like to follow my project blog, it's available at handmap.github.io, and I update it regularly with tutorials and walkthroughs and basically everything that I do on this project, and it'd be great to get some input from people. Alternatively, you can follow my GitHub repository at github.com/handmap. And finally, if you'd like to send me an email, I'm available at nathan@clovers.id.au. If you are having problems or have dealt with OpenCV in the past and would like some guidance, I'd be happy to help out.